zoom in a little bit so you can see this better. So lesson 4 talks about scale drawings and models. And it tells us that scale drawings and models are used to represent objects that are too large or too small to be drawn or built at actual size. So we talked about some examples of this today. That would be something like a map, or we've talked about how you might make a scale model of a building if there's like a skyscraper that you're going to build and you want to present what it's going to look like. You might make a model for that. We've talked about that you guys have all made models of the solar system. Those are too big to actually make it the real size, so you had to make a model of them. In science class, you talk about a lot of different things like cells that you can't actually see them. They're too small to see, so you have to make them at a different size to have a model of them. The scale is what tells us how the measurements of the drawing or model compare to the measurements of the real object. If you're looking at a map, your scale tells you what the model is compared to the actual. And then the last thing it says is the measurements the measurements on a drawing or model are proportional to the measurements on the actual object. So all of these are drawn proportionally. Just like if you have ever seen the movie Honey, I Shrunk the Kids shrink down, but they still look exactly the same. They don't have one ginormous eyeball or a really small ear. They have shrunk down proportionally, so they all look exactly the same still. They're just in a smaller form. So when we go to look at this, to solve today, we are going to work proportionally. A zoom is like actually helps you kind of see proportional. I have it zoomed. Notice when I zoom out, it still looks exactly the same, just smaller, so it's still proportional, okay? So here it says, on a map, the distance from Akron to Cleveland measures 2 centimeters. What is the actual distance if 1 centimeter equals 30 kilometers? And we should put a question mark there. Okay. So since we know they're proportional, you can solve using a proportion. And you always want to do this by putting the models on the top and actual on the bottom. Okay. Always use those labels. I know it's one extra step, but it really will help you put things in the right spot. So the easiest way is to start off with your scale. This is my scale telling me how the model compares to the actual. So the model is the 1 centimeter. The actual is the 30 kilometers. And then the other number that I know is the 2 centimeters. The 2 centimeters is the distance on the map, which is my model. You also can make sure, okay, centimeters matches up with centimeters. So I know this bottom, when I find it, will also be kilometers. And then you solve with the proportion, which you know you do your cross products. So you would do, you probably don't even need the calculator for this one. 1 times x is 1x. 30 times 2 is 60. From there you would divide by the coefficient, but when you divide by 1, it's going to be the exact same thing. So you know it's 60 kilometers to go from Akron to Cleveland. The next one says an engineer makes a model of a bridge using a scale of 1 inch equals 3 yards. The length of the actual bridge is 50 yards. How long is the model? So we look at this, and again, you always put model on top, actual on the bottom. Start with your scale. So we know in the model 1 inch is equal to 3 yards in real life. From there, your other number is 50 yards, and it says the length of the actual bridge. So we know that's the real bridge. We're trying to find the model. Again, do your cross products. 3 times x is 3x. 1 times 50 is 50. Then you divide by the coefficient, so you take 50 divided by 3, which is 15.6 repeating. Now, if you know what 0.6 repeating is as a fraction, which I do, it's 2/3, you can write 15 and 2/3, and then you would have inches as your label. If you don't, you can always round on this one. It usually won't tell you in this problem. I would take it if you leave 15.6 repeating, or 15.7 would be fine. The last thing we need to talk about is the scale factor. And we're going to look in the book to talk about the scale factor again. Scale factor is talking about a scale written as a ratio without units in simplest form. So first of all, a scale factor written as a ratio. Remember, to write it as a ratio, you can put it into a fraction. Then without units. So to cancel out the units, they have to be in the same units. Inches and inches, yards and yards, miles and miles. Then once you cancel them out, you have to make sure it's in simplest form. So you cannot have a decimal inside of a fraction, and you can't have a complex fraction, which is a fraction within a fraction. Okay? So when we look at this, first write the scale as a ratio. 1 centimeter over 1 meter. Then we need them to be in the same units. Now, if they were already in the same units, you could just take them off, and that number is your answer. But since we need them in the same units, you always want to go down to the smaller unit. That's the easiest way to do it. So 1 centimeter, since it was already centimeters, we're going to keep it the same. This one we need to change to centimeters. Well, hopefully you know that centimeters to meters, there's 100 centimeters in 1 meter. So that would be 100. Now, do you see, hopefully you see, those mean the same thing. 1 centimeter compared to 1 meter is the same as comparing 1 centimeter to 100, because 100 centimeters is a meter. Alright? Once you have it converted into the same units, you can cross those out. And as long as your number's in simplest form, that's the scale factor. And the scale factor tells you how much bigger or how much smaller something is, the model is, compared to the original. The next one, again, write it as a ratio. So 1.5 inches over 2 feet. Make them into the same units, so we'll put them into inches. So 2 feet, well, we know each foot has 12 inches, so that has to be 24 inches. And then this isn't in simplest form. You want to get rid of having a decimal. And so the easiest way to do that, I think, is you can do you can move the decimal over one spot. Well, if I move it over one spot here, to move it over one spot there, which would be 15 over 240, and simplify. Or the other thing is you can pick a number and multiply both the top and the bottom by that. Like if I multiply by 2, that would give me 3 over 24 times 2 would be 48. And you can see here, if you would have simplified, 15 divided by 5 is 3, 240 divided by 5 is 48. You would have gotten the same answer no matter what. And you can actually simplify even more. That would be 1 over 16. So in this case, our scale factor would be 1 over 16. Those are a little bit trickier, I think. So if you ever have questions on that, come see me. And the last thing is, you might have a homework problem that asks about finding the area. If you have a problem like that, Look at example 4. Example 4 shows you how to find the actual length and the actual width, and then what to do to find the area.